Hello and welcome to another Ginger Mathematician video. This time I'm going to go through all of iGCSE Add Maths, so 0606 Add Maths, everything you need to know on trigonometry. So by the end of this quite long video, you'll have a very good idea exactly what kind of questions come up, those kind of patterns and the skills that you need to do to succeed. Now before we start, the identities that you need to know are written here. So remember, you need to know these very well. And you also need to know the definitions of sec, cosec and cotangent. Remember, sec of A here, for example, is equal to 1 over cos A. And then cosec A is equal to 1 over sine A. And then we have cot, so don't forget that our cotangent is equal then to either 1 over tan A. But you can also write this, of course, as cos A over sine A. These are generally very, very useful as we go through these questions. All right, let's get started. And this is very, very typical, a show that question. So you need to show that the left-hand side is equal to the right-hand side. And this is generally the way we approach these questions. So I'm going to write down left-hand side is equal to 1 plus tan theta over 1 minus cos theta plus 1 minus tan theta over 1 plus cosine of theta. And what we're going to do is make it look like the right hand side. Now the first thing I notice here is we have one single fraction. So as soon as I see one single fraction, we need to combine these together. The way that we do this is by having the common denominator, and the easiest way to do that is just multiply them together at the bottom. So what I'm going to do is I'm going to write both fractions in terms of 1 minus cos theta, 1 plus cos theta. So we're going to have two fractions, and we're going to make sure this denominator is shared with both fractions. So it's all about setting this up correctly, and then we'll sort out the numerators afterwards. So if I look at this first fraction here, we're going to multiply top and bottom here by 1 plus cos theta. So we're going to get ourselves 1 plus tan theta times 1 plus cosine theta. So all I've done to this fraction here is just times top and bottom by 1 plus cos theta. And here, kind of the other way round, I'm going to multiply top and bottom by 1 minus cosine theta, kind of unsimplifying the fraction here. Once we've done that, well, we can do a lot of simplification at this point. So if we multiply out the top here, we get 1 plus 2 cosine theta tan theta let's try again. So we get 1 plus, I know lots of things are going to cancel here, 1 plus cos theta plus tan theta plus cos theta tan theta. Okay, I'm going to put dot 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 just to represent the bottom here. Again, trying to save myself a bit of time in the Add Maths exam. And if we do the same thing here, we get, well, a 1 here. We get a minus cos theta minus tan theta. Remember, two minuses here make the plus, so we get plus cos theta tan theta. And because we have the same denominator here, we can just add the tops together. So notice we have a cos theta and a minus cos theta, so they cancel, plus tan theta minus tan theta, that cancels. So when we're left with here, 1 plus 1 is 2, and then on the top here we get 2 plus 2 cos theta tan theta. Now if we take the bottom here, notice it's one of these difference of two squares. So if I take this bottom here, so if we multiply this out, we actually just get 1. The cross terms cancel and we get minus cos squared theta. So the bottom is one of those very nice simplifications here. And now we just need to tidy this up to look like this. First thing to do is use the bottom part, so 1 minus cos squared theta. If we go back to the formula sheet, is a rearrangement of this one. So if we rearrange this, cos squared theta, sine squared theta, is equal to 1 minus cos squared theta, or a in this case. So if I go back to this, I can just remove the bottom and just change it to sine squared theta directly. So we're making progress in terms of the show that question. And now here at this point, well, we can take a factor of 2 out. Notice there's a factor of 2 here. So we get 2 brackets 1 plus cos theta, tan theta. And so we're almost there. You can almost smell that the answer is there. The thing to realize here is that if we've got cos theta, tan theta, and we multiply together, remember tan is the same as sine over cos, which I mentioned earlier. So it's sine theta over cos theta, and therefore these cancel, leaving us just with sine theta. So we can replace cos theta tan theta here with just sine theta, and now we get exactly what we want, 2 plus 1, 1 plus sine theta over sine squared theta, which is the right hand side. And we've shown that the left hand side here is equal to the right hand side, like so. Now generally with these kind of questions it leads into some kind of solving, and this question is no different. Notice we have this word hence. Really important in Add Maths, also A-level exams as well, and IB. So this basically is telling you use part I, use what we literally just did. Because notice here, the left-hand side is exactly the same as the left-hand side here. And this time we just want to make it equal to 3 and solve. So using part I, we're going to replace the whole left-hand side here with the right-hand side we just calculated. So we get 2 brackets 1 plus sine theta over sine squared theta is equal to 3. And this essentially is a quadratic trigonometric function that we're going to work our way through and solve that equation. So the way we do this, first of all, we're going to remove the denominator. So what's the opposite? Dividing by sine squared theta, we're going to times by sine squared theta on both sides, like so. This cancels, so we get here 2 brackets 1 plus sine theta is equal to 3 sine squared theta. Expand the bracket here, so we get 2 plus 2 sine theta is equal to 3 sine squared theta. Now we're going to bring everything to one side here. So I'm going to bring everything to the right hand side. So this is then going to become 3 sine squared theta. Again, we're going to do a minus 2 sine theta and a minus 2. So why we've done this is that we made this left hand side 0 and got it in this quadratic form. So the first thing to check is, does it actually factorize? Because that would save us a lot of time. So if it is going to factorize, then we should be able to put it into brackets like so. But hopefully you've got some good experience of quadratics. Again, if you want to check out some work on quadratics on the A-level course, check out the video above. But we notice here we can't put the 2 and 1 in such a way that this actually works. So we should always check these things first. Okay, but then we have our second possibility, which is using the quadratic formula. Again, I try and avoid it when I can, but in this case, yeah, you have to do what we have to do. So if we use the quadratic formula here, quick reminder that the quadratic formula is minus b. You probably have it memorized by now in Add Maths. B squared minus 4ac all over 2a. Remember, a, b, and c correspond to the coefficients. In this case, the a here is 3. The b is minus 2, and then c is also minus 2. So if we substitute it in, we get 2 plus minus the square root of b squared. So minus 2 all squared, that gives us positive 4. So be careful with that. 4ac, so 4 times 3 times minus 2, all over 2a, so that's equal to 6. 3 times 2 is 6. Be careful with that. You often assume it's 2, but of course not in this case. If we work our way through this, so we get 2 plus minus, we get 4. We're going to get a plus out of this, which is always good. So 1224 over 6. And if we simplify this down, so 2 plus minus root 28 over 6. And now we can take a factor of 2 out here. So all I'm going to do is simplify the surd here. But the square root of 4 goes into this. So this becomes 2 root 7. Again, those surds are always very important. Because now we have a common factor of 2 in everything, we can cancel through. So we get 1, 1, and 3 there. So we get 1 plus minus root 7 over 3. So you get two possible answers for sine. So you've got 1 plus root 7 over 3 and 1 minus root 7 over 3. However, if we check on the calculator here, okay, this is always a useful thing to do, 1 plus root 7 divided by 3. That gives you a decimal of 1.215. So I'm going to show this up here. 1 plus root 7 over 3. Now the problem with that particular answer is that sine being equal to that, that's not a possible solution because the range of sine is between -1 and +1. So this is not a solution. So the only solution we can take here is 1 minus root 7 over 3. So let me just create a new slide. We're running out of space. Now I've got the last part of the question to finish off. So it's very important to identify which solutions are possible. So you do have to double check, okay, is the solution here's for sine theta between 1 and -1. Now if we actually do this on the calculator, so 1 minus, just to show you what's going on here, and divide by 3, we get here is minus 0.5485, which is fine because it lies between -1 and +1. And now we just need to solve this. We need to check the domain we're given here between 0 and 360 degrees. So we're working in degrees here as well. The easiest way to do this is first of all, let's just find out one solution. So the opposite of sine is inverse sine. So we do sine inverse of this. Let's write it as a fraction. 1 minus root 7 over 3. So if we do that and do sine inverse of that, and make sure your calculator is in the right mode, I had it set up in radians, and that's something you have to be quite familiar with here, making sure you can convert between. So let's try that again. So sine inverse 1 minus root 7 divided by 3, almost there. Yeah, good. And we get minus 33.269 dot dot dot. Okay, however, that's not a solution because that doesn't lie between 0 and 360. So I'm going to draw a quick sketch here of the sine function. Again, you should be used to this from standard maths as well, where I'm going to extend this slightly here. The sine graph goes between 0 and 360 here, so we're going to go like so. This is our graph. However, what we've done here is we've worked out this solution. So this here of minus 33.269 dot dot dot. And we actually want the solutions over here. So this solution and this solution. So we want to read both of these off. Now the way I generally teach this, again, it's good to visualize what's going on here. This length is the same as this length, which is the same as this length. So that's useful to be aware of. This point here, again, you should know your sine graph very, very well. And by the end of this video, you certainly will. This is 360. So to work out the answers we're looking for here, we want to do 180 plus 33.269 dot dot dot, and we'll work that out in a moment. And to work out this one, we want to do 360 minus that black area, so 360 minus 33.269 dot dot dot. So if we pop this in, let's do the bottom one first. That gives us 326.7 degrees to one decimal place. And if we do the previous one as well, let's just quickly work this through. Okay, and then we're adding on 180, and that gives us then 213.3 degrees to one decimal place. And we've got our answers. So lots of different skills in this particular question. This is a little bit overwhelming at this point. Then we're going to do lots and lots of practice. It's the great thing about this video. By the end of this video, feeling much more secure with solving trig functions, using trig identities. So it does take practice, and stick with this video. You will get better at this topic. Okay, so that's the mark scheme there, so you can see where you're picking up those method marks and also those accuracy marks at the end. Okay, and on to this question here. Again, a very typical style of question they like on Add Maths. So we're given that tan theta here is equal to root 3 minus 1 over 2 plus root 3 between 0 and pi over 2, and we want to find cosec squared theta in this particular form. Now the first thing to realise here is use that formula sheet, because we know that cosec squared theta is equal to 1 plus cot squared theta. So that comes directly from the formula sheet. And remember, we actually have tan theta here, which is equal to root 3 minus 1 over 2 plus root 3. And remember, if we take cot theta, it's basically 1 over tan theta. So we just have to flip the fraction here. So we get 2 plus root 3 over root 3 minus 1. So we pop this into our formula. So we get then cosec squared theta is equal to 1 plus, and we now have what cot is. So we have 2 plus root 3 over root 3 minus 1 all squared. So all we need to do here is multiply this by itself. So we're going to do lots of working with surds in this particular question, which is not unusual on Add Maths as well. So really get up to speed with how to do this. Now, if we want to put these together, so if you times the tops here, we get 4 plus 2 root 3. So make sure you're thinking about this in terms of double brackets. So multiplying everything by everything. So 4, 2 root 3, 2 root 3. And then we get root 3 times root 3 is just 3. If we do the bottom part here, root 3 times root 3 is 3. And then we have minus root 3, minus root 3, minus 2 root 3. Minus 1 times minus 1 is plus 1. So this will then become 1 plus 7 plus 4 root 3 over 4 minus 2 root 3. At the moment it's looking kind of strange here because we need it as one very clear term here, and the way that we do this is kind of unsimplifying the 1. So we're going to make the 1 into just 4 minus 2 root 3 over 4 minus 2 root 3. Essentially, because if you simplify this and just cancel top and bottom, you get 1. But this then gives us the opportunity to then pop this as one particular fraction. So we just add the numerators here. 7 plus 4 is equal to 11. Minus 2 root 3 plus 4 root 3 is plus 2 root 3. And then the denominator stays the same. Now at the moment this is not in the form that they want. They want it as just a plus b root 3. And the way that we do this is do some rationalizing. So if I just write this on the new slide. So we've got 11 plus 2 root 3 over 4 minus 2 root 3. All we're going to do here is, again, make sure we rationalize the denominator by multiplying by the conjugate. So we're going to multiply by 4 plus 2 root 3 and divided by 4 plus 2 root 3. Again, we've got another set of double brackets to work our way through. Let's just be patient and we will get there. So if we do the numerator first, let's just be very careful how we do this. So making sure that we do follow first inside, outside, last. So we get 44 as the inside. We get 22 root 3 plus 8 root 3. 2 root 3 times 2 root 3, that's going to be equal to 12. Because if you unsimplify this, this just becomes root 3 times root 4, which is root 12. Root 12 times root 12 is 12. Hopefully that wasn't too quick at home. If we do the same at the bottom, 4 times 4 is 16. The cross terms we know is going to disappear anyway. And then minus 2 root 3 times plus 2 root 3 is minus 12. Using what we already did in the numerator. Simplify this down, then we get 56 plus 30 root 3 over 4. And it's not quite in the form that we want at the moment. Again, we want it in this a plus b root 3 form. So we can split this up. So 56 over 4 plus 30 over 4 root 3. Again, you do have a calculator, so do use it as you go along. So we get 14 here. And then 30 over 4. I prefer writing this as a fraction. I think it probably doesn't matter. 15 over 2 root 3. And we get the answer because we then get the constants a and b here, like so. Okay, so you can check through the mark scheme here. So again, I've just taken this essential idea here of working our way through. Yeah, I think I just did this method down the bottom, alternative 1. Again, there's a couple of alternative approaches you can take. And onto a very similar looking question here. We've given here that x is equal to sec squared theta, y plus 2 is equal to cot squared theta, and we want to write y in terms of x. Okay, so the first thing that comes to mind here is we've got y plus 2 is equal to cot squared theta. So that means then that y is equal to cot squared theta minus 2. Okay, so if we take the x equals sec squared theta, then if I rewrite this out as 1 over cos squared theta, I told you these definitions are very important to know here. Now we can do a little bit of rearrangement here to fit it into this cot squared theta. So we can then say that cos squared theta is equal to 1 over x. So just times by cos squared theta dividing through by x. So that's useful. We're going to need that later on. Remember that cos squared theta is also equal to 1 minus sine squared theta. Again, all from the formula sheet here. So that's equal to 1 over x. And again, we can rearrange this slightly. So we get sine squared theta equals 1 minus 1 over x. So what I've done here is use that x part to work out cos squared theta in terms of x and also sine squared theta in terms of x. Now we're going to use a factor we've already looked at in a previous question here, which is that y is equal to, well, cot squared theta is equal to cos squared theta over sine squared theta. And now we can substitute these two things in that we've already got here. So cos squared theta is equal to 1 over x, and sine squared theta is equal to 1 minus 1 over x. Okay, so this looks kind of untidy at the moment, but that's absolutely fine. You should be aware that the algebra might get very, very nice, in which case we just have to do a little bit of work on this. So first of all, I'm going to do a very similar trick to what I looked at before, which is I can rewrite 1 as x over x, like so. And this allows us then to just collect up the numerators. So we get x minus 1 over x minus 2. And now at this point, all I have to do here is just times top and bottom of this fraction by x. It doesn't change what it is. So if I times the top by x, I just get 1. If I times the bottom by x, I just get x minus 1. And I assume they are happy with that as the answer. So this is what y here is equal to, because we just have y all the way through here. Y is equal to this, y is equal to this. So I would probably leave it at this form. It'd be interesting to see what the mark scheme says. And they are happy with that. Yep, so we just did this answer. You could, I'm going to quickly show you how to do this. You could also just rewrite this as 1 over x minus 1 minus 2 lots of x minus 1 over x minus 1, and then simplify this. That's also possible. Well, I like this form. I think this is quite a nice form to work with, particularly if you do some graph sketching, asymptotes and things like this. So you can check the mark scheme here, and you can have a look through how we approached it. So I went for this kind of alternative approach down here. Again, but there's many different ways you can approach this kind of problem. Right, on to the next question. So we're solving this not very nice looking equation. Our domain here is between 0 and pi. So we're working in radians this time. So between 0 and 180 degrees. And give your solutions in terms of pi. Right, the key thing is not to be intimidated by this and just work your way through. So the first thing that we'll do here is just divide by 3 on both sides. So cosec squared 2 phi minus pi over 3 is equal to 4 over 3. We're going to square root both sides, so that gives us then cosec 2 phi minus pi over 3. And we're square rooting top and bottom. So we get plus minus, so keep that in mind. Square root of 4 is 2. Square root of 3 is just square root of 3. They've got cosec at the moment. Now remember cosec, you really need to know these very, very well. Theta is just equal to 1 over sine. So what we can do is just flip both sides. So we get sine 2 phi minus pi over 3. Sorry, a little bit croaky, which is plus minus root 3 over 2. As soon as you see root 3 over 2, you'd be thinking, yes, an exact value. You'd have to use the calculator too much, which is really, really helpful. So we want to then work out the inverse sign of both. So we'll do this in parallel here. So I'll put 1. So we'll look at the positive version first. And then we'll look at the negative version afterwards. Again, there's a few different approaches you can take here with unit circle. That's absolutely fine as well. But I think I'll just separate this out into two distinct problems, just so we don't forget the minus as well. That's something to consider. Okay, so what we do here is we're going to work out the inverse signs. We want to cancel through that sign. So 2 phi minus pi over 3 is equal to the inverse of root 3 over 2. Again, you really should know your exact values here. Again, you can check this on a calculator, but this is going to equal, at least one of the answers, is going to equal 60 degrees or pi over 3 radians. So if we think of the graph here, because we need to use the sine graph, and working between 0 and pi, we'll come back to that in a moment. So if you've got your graph here, this is sine, keeps going, and going, and going, like so. And we've worked out the pi over 3 answer. So we've worked out this answer here, pi over 3. This is here, root 3 over 2. But we need all the answers, yeah? So we need this one, and we need the one over here, and so on. So this one here, just by using symmetry of the graph, so this is pi here, so this is pi over 3, this is pi over 3, badly drawn. So this is going to be 2 pi over 3. Now if you ever get stuck with, okay, is 2 pi over 3 really an answer? Put it into your calculator, yeah, and you can check that you do get root 3 over 2 afterwards. However, because we've got this 2 in front of the phi, we are going to need some more answers here. So we are going to need this one over here. Now this is 2 pi, which is 6 pi over 3. So we also need 7 pi over 3. Means we're going to need 8 pi over 3. And that probably should be enough, but you'll see what I mean as we go along. So what we're going to do here is get phi on its own. So first of all, we're going to add pi over 3 on both sides. So that cancels, leaving us 2 phi. So just adding pi over 3 to each of these. So 2 pi over 3, pi, 8 pi over 3, 3 pi. And now we divide by 2. Now what we're looking for here is making sure our answer lies within this domain. So if we divide by 2 now on both sides, we get phi is equal to 2 pi over 6, which is pi over 3. So that fits, that's fine. This becomes pi over 2, that also fits. And then we get 8 pi over 6, which doesn't fit because it's beyond the range. So we can stop there. So pi over 3 and pi over 2 are answers for this one. And we do this one in a very similar way. Now, you don't actually have to use your calculator here. You can just use the symmetry of the graph if you so wish, but let's just do this anyway. So 2 phi minus pi over 3 is equal to inverse sine of minus root 3 over 2. And let's see what answers we get here. So you can notice it's kind of symmetrical here. So we have minus pi here. And this is going to give us, I think, minus pi over 3. Because we're going to read off this answer. Notice we're going to get these two answers over here and over here. So we get minus pi over 3. Now we want this answer, so this is 1 extra than 3 pi over 3, so it gives us 4 pi over 3. And now, because we want to read off these two answers over here, and then we want to work backwards, so you can have 5 pi over 3. I suspect that's probably enough, but we could go on if we wanted to. Then we're just going to add pi over 3 on both sides, so we get 2 phi If we add pi over 3, we get 0 here. 5 pi over 3, and here we get 2 pi. And now if you divide through by 2 here, well, that's still going to give us 0. We get 5 pi over 6 and pi. But notice, look at the inequality symbols. Again, it's strictly less than or strictly more than. Therefore, these two answers are not valid, but this one does lie within the domain. So our final answer here, final answer is equal to pi over 3, pi over 2, and 5 pi over 6. Okay, you have to be very careful with these questions. Just work your way through very, very steadily, and then you'll get to the right answer. Okay, and now we've got another find y in terms of x question here. So again, we've got cos x squared, and we've got y plus 1 equals tan. Find y in terms of x. So always read that sentence here. So I'm going to start with this one over here. So y plus 1. And see these questions quite similar to what we've seen before. We minus 1, we get tan squared theta minus 1. And now we want to use the formula sheet. So back we go, all the way to the formula sheet. Making a point here is that we use it often. And so we're going to use the one at the bottom, I think, here, or the top one, sec squared a. Then we can choose which one we want to use. Let's go through lots of work we've done so far. What would be the easiest thing to do here? Okay, let's start with cos x squared theta. That's 2x minus 1. So that means then, okay, sine squared theta is equal to 1 over 2x minus 1. I think this is probably the easiest way to go. And now we can use the sine squared theta is equal to 1 minus cos squared theta. And do a quick rearrangement. You see this question is very similar to what we saw before. And that gives us then cos squared theta is equal to 1 minus 1 over 2x minus 1. And now we can substitute this in, because remember tan is equal to sine over cos. And now we can substitute in what we have. So we get 1 over 2x minus 1 and 1 minus 1 over 2x minus 1 minus 1. Again, a similar trick to what we did here. So what I'm going to do with the denominator, I like testing this kind of question, yeah? We're going to do 2x minus 1 over 2x minus 1 minus 1 over 2x minus 1. So we write it as one fraction, basically. That gives us then 1 over 2x minus 1. There we are. 2x minus 1 minus 1 is 2x minus 2 over 2x minus 1 minus 1. And now we do this trick that we saw before here, which is we multiply top and bottom by 2x minus 1. And that gives us then 1 over 2x minus 2 minus 1. And looking at the mark scheme from before, I'm assuming they are happy with this way of expressing it. So yeah, you can see that's the answer down here that we did, and then the answer to the previous question. So pi over 3, pi over 2, and 5 pi over 6. This is where the mark scheme is not very helpful, because it tells you up to this point and then just generates these answers. But you really do need these videos to go through and say, this is why I did X, Y, and Z to get through to these three answers. Okay, and on to our next question. If you're liking the content you're seeing in front of you so far, then do think about subscribing, because there's tons of Add Maths content coming, A-level content and iGCSE content you don't want to miss. Right, let's continue. So the function f here is defined as f of x equals 3 sine squared x minus 2 cos x. Interestingly, our domain here is between 2 and 4. That's going to be crucial for this question, and we are working in radians. So first of all, we need to find the x-coordinate of the stationary point on the curve y equals f of x. As soon as you see this phrase, stationary point, you need to be thinking first derivative and then setting that first derivative to 0. First thought that goes to mind. So if we take our f of x, which is equal to 3 sine squared x minus 2 cos x, even though this is not a calculus video, it's a useful skill to have anyway, and it's going to tie in with the trigonometry we do later on. So in order to find the derivative of this, Again, think of this 3 sine squared x as 3 sine x all squared. So we're going to be using the chain rule here. So in order to differentiate this, we take the 2, we bring it to the front. So 2 times 3, that's equal to 6. We differentiate what's inside the bracket. So sine differentiates to cosine. And then we reduce the index by 1. So that just gives us sine x, or sine x to the power of 1. If we differentiate the minus 2 cos x, be very careful here. Cos differentiates to minus sine. So we're going to get a plus 2 sine x, like so. And now we want to find this stationary point, so we need to take that first derivative and set it to 0. So we get 6 cos x sine x. And this is where now the trigonometry comes in. Plus 2 sine x is equal to 0. And again, we can take a common factor out here of a 2 and a sine x at the same time. And let's see what we get left in the bracket. So what do I multiply 2 sine x by to get 6 cos x sine x? Well, a 3 and a cos x. What do I multiply 2 sine x to get 2 sine x? Well, just 1. And now we've got an equation that we can solve, because if two things multiply to give you 0, one of them has to be 0. So either, and we'll start with one at a time here, 2 sine x is equal to 0. Therefore, sine x must be 0. And if you think about how the sine graph looks here, again, nice quick sketch. It starts at 0, come up, down, and then round like so. Okay, we're working in radians here, so it crosses here at pi and here at 2 pi, between 1 and minus 1. So when is sine x 0? Well, it's 0 here at 0, at pi, and at 2 pi. So x is equal to 0 pi 2 pi, and this continues. However, we need to pick the answer that's within our domain. So notice here 0 is not between 2 and 4. Pi is approximately equal to 3.14, so that is an answer. 2 pi, however, is about 6 point something, so that's too big. So the only answer from this domain here is x is equal to pi. Let's check the other bracket now. So or 3 cos x plus 1 is equal to 0. Therefore, cos x is equal to minus a third. So if we want to find one of the answers here, what's the opposite of cosining? Well, inverse cosine on both sides. This cancels, so we need to find the inverse cosine of minus 1 over 3. And let's see what the calculator gives us here. Again, remember, we're working in radians, so your calculator is not in radians. As you can see here, I am changing it directly into it. So inverse cosine minus 1 over 3, and that gives me 1.91 c. So if we think about a cosine graph and how that looks like, just so we can see this in action, starts at 1, comes down, not at pi over 2, round, up, and then round. We're working out minus a third here, so this is our value here, and we've just worked out that value here is equal to 1.91. So we also need to check this value over here. Remember, this is equal to excuse me, it's a bit of a cough. This value here is equal to 3 pi over 2. You need to know these graphs really, really well. And then this value here is pi over 2. So in order to work out whether the other solution is within our domain of 2 and 4, we take this answer, we're going to minus pi over 2 from it, because it's 0.333, and then we're going to take 3 pi over 2, so 3 pi over 2, and then minus the answer from that. That gives us then 4.37 ... c. These two answers, again, are not within our domain, so not within between 2 and 4. So therefore, the only answer to this actual problem for the whole 5 marks is just x is equal to pi. Now on to the second part of this question. Solve the equation f of x is equal to 1 minus 3 cos x. Now we know what f of x is from the previous question, so let's copy it across. 3 sine squared x minus 2 cos x is equal to 1 minus 3 cos x. And again, we've got another trigonometric equation to solve. Key thing with these kind of problems is you want it all in terms of cos or all in terms of sine. And we're going to use one of the identities in the formula booklet. Excuse me. So which is that sine squared x is equal to 1 minus cos squared x. So a rearrangement of that formula there. So if we substitute this in, we get 3 lots of 1 minus cos squared x minus 2 cos x is equal to 1 minus 3 cos x. Now we just multiply out the single bracket here. So just take your time with these questions. Again, absolutely no rush at all. Making sure you're confident with the algebra you're doing here. Again, we've got a quadratic trigonometric equation. So you want everything on one side and the other side being 0. So if we do this, I'm going to, in this case, add on 3 cos x and also minus 1. So we get 2 minus 3 cos squared x plus cos x is equal to 0. Now I don't like negatives here, so what I generally do is just multiply through by minus 1 on both sides. This has the effect of making this positive, but then the other two things here negative. Now the first thing you should always try and check is, does it factorize? So I will always give this a try, because I generally don't want to go to the formula unless I'm absolutely forced to. And let's have a think here. Can we find out a combination that works? I think we can. We put a minus 2 here and a plus 1. If we check those cross terms, 3 cos x times 1 is 3 cos x, minus 2 times cos x, minus 2 cos x, 3 cos x, minus 2 cos x is just plus cos x. So notice we've got the right idea here, but we just need to switch over the signs. So this is why I double check these things. So we pop in minus 1 here and plus 2, double check. So if we do double check, minus 3 cos x plus 2 cos x minus cos x. Perfect. So therefore, cosine of x is either equal to 1 or 3 cosine of x plus 2 is equal to 0. So let's solve these two equations. So this first one here, cos x is equal to 1. Well, if you think of the cosine graph, this is why a good sketch is very useful. It's only 1 at 0 and 2 pi. So right here and right over here. So let's write down those two answers. Notice our domain is still the same here. So it's still between 2 and 4. So I think we can discount both of these answers. And now let's look at the other equation. So if we solve this, cos x is equal to minus 2 over 3. So again, we want to do the inverse cosine to get x on its own and read off the answers that we're looking for. This cancels. And if we do the inverse cosine, and make sure it's in radians, big mistake that students make. The first answer we get here is 2.30 ... radians. So if I draw a quick sketch of this, excuse me, again, you really need to know your cosine graphs and sine graphs really, really well. So we come down to here, down, up, and around. This here is a pi over 2. This is 3 pi over 2. And this would be here pi. And we've worked out this time minus 2/3. So it's going to be down here. So we've worked out this answer, which does fall within our domain of 2.300. But we also want to check if this answer also fits in our domain. So this length here is the same as this length here. So we're going to do this very similar to how we did the previous question. This is why this video, do watch through these questions nice and carefully. So we want to find the distance between 2.30 and pi over 2. So I'm going to do minus pi divided by 2. Gives us 0.729. And then we're going to take 3 pi over 2. And minus that from the answer we just had. So our other solution here is 3.98, which just about falls into our domain between 2 and 4. So these are our two answers for this particular equation. The domain here was critical and realizing working in radians to get the answers of 2.30 and 3.98. Right, so you can check the solutions here. Again, it's very important you discount these answers and show the working for that to make sure you're getting all those method marks in between. And 8b also works here as well. Notice no extra is very important, so let's be very clear. Okay, these two answers are the answers for the question. Okay, and on to our next question here. So first of all, we need to factorize this. So 6xy plus 3y plus 4x plus 2. And generally I take the splitting the term approach here. So I divide it down the middle. I take out the common factor here, which in this case is 3y in both. And then what do I do to 3y to get to 6xy? Well, 2x. What do I do to 3y to get to 3y plus 1? And then here, take out a factor of 2. And notice we get exactly the same factor in both brackets. It's been set up in that very nice way here. And therefore, our final answer will then be that bracket, 2x plus 1, which comes to the front. They want the x in the front here. And then 3y plus 2. So I think I'd just be very clear in a question like this. And that's a 1 mark question. A is 2, B is 1, C is 3, and D is 2. And now we've got that keyword hence. We've seen this a lot in this particular video. So using what we have, can we actually work out this one? Notice, in this case, we've got 6xy. Well, in this case, our x would be the sine theta and the y would be the cos theta. Notice it follows the same pattern all the way through the question. You should always double check that. So therefore we can take our answer. Wherever we see an x, we put a sine theta. Wherever we see a cos theta, we put a y. Other way around. So we get 2 sine theta plus 1 multiplied by 3 cos theta plus 2 is equal to 0. Notice our domain this time is in degrees, so get that calculator changing. And now we need to solve these two separately. So either, we'll start with the easier one here, 2 sine theta plus 1 is equal to 0. Therefore sine theta is equal to minus a half. As soon as you see minus a half, you should be thinking exact values, but again, you have a calculator, so why not use it? We do the inverse sine of both sides, that gives us theta. And again, changing my calculator very quickly to degrees. So we're going to do inverse sine of minus 0.5. And that's going to give us the answer of minus 30. Now, notice that is not in our domain, so we can't use that answer. But we can do a quick sine sketch here just to show you what's going on. So we're going up and down, up and down. This continues a little bit further. So we've just worked out this value. So this is minus a half here. And this is at minus 30. But we want to work out the answers within our domain. So this one here and this one here. So this length here, let me do this in black. This here is equal to 30. So this needs to be 30. This needs to be 30. This here is 180, 360. So then this value will be 180 plus 30, which is 210. And then this value is 360 minus 30, which gives you 330 degrees. Those are the only answers within the domain that we have. Because notice we're only going between 0 and 360. So my graph matches the domain I have in the question. And now we look at the more complicated example. So 3 cos theta plus 2 is equal to 0. Gives us then cos theta is equal to minus 2/3. So then we do inverse cosine of both sides here. Getting kind of in the swing of it by this part of the video. So if we do inverse cosine here, we do a very similar approach to how we did the previous one. Yep, we get 131.8 ... degrees. Now that is within our domain, so that's going to be one answer that we have. If we just draw a quick sketch of a cosine graph. And once you know these, you don't have to do these sketches all the time. You know what is going on. So we've got this one here. We have minus 2/3. So that was the one down here. And this is 131.8 degrees. Okay, now we're working in degrees. So this is 90. This is 270. And we want to work out the answer over here. So this, using the symmetry of the graph. So we've got this length here. It's a difference between 131.8 and 90. And this here is also that as well. So in order to work out the answer, we do this minus this. And then this gives us the black length, which we can take away from 270. So we do minus 90, 41.8. and we do 270 minus that answer, giving us the other solution here of 228.2 degrees. So we get 4 solutions for this one. And again, using that graph, that sine and cosine graph, that's so critical on the Add Maths course, is really, really important. You don't need to draw a sketch of that necessarily in the exam, but you do need to have an understanding of, okay, we're looking at the particular domain 0 to 360, how do I find those solutions? Okay, and now we'll go on to question B here. So now we've got to solve the equation, looking not very nice here, a half sec 2 phi plus pi over 4 is 1 over root 3. Again, now we're working in radians here, so keep that in mind to get that calculator changed, and give your answers in terms of pi. So generally we're not going to be using the calculator too much. So the first thing that comes to mind here, so half sec 2 phi plus pi over 4 equals 1 over root 3. The first thing to do here is get sec on its own. So we're going to times by 2 on both sides. First of all, so that gives us 2 over root 3. Now remember sec theta, and we've talked about this a lot, is equal to 1 over cos theta. So what I'm going to do here is change this now to cos, but I need to flip the fraction, which is nice because it gives us an exact value here of root 3 over 2. Now we want to remove that cosine, so we're going to do the inverse of cosine on both sides. So this cancels, giving us 2 phi plus pi over 4. And now again, make sure you change your calculator to radians, constantly going between radians and degrees. So if we do inverse cosine of root 3. You should know this anyway at home. Excuse me. But the calculator is quite good here. We'll give it in terms of pi for you. So one answer here is equal to pi over 6, which is the same, of course, as 30 degrees. Now, if we do a sketch of cosine, just so you can see all the different solutions here. So we go down, down, up, and then we repeat again. You're wondering, why am I drawing an extra part? You're going to see this in a moment. So if we have pi over 6, that was root 3 over 2. So let's pop that in roughly here. This is pi over 6. This here is pi over 2. Again, my diagram not very good to scale, but it will be fine. This is 3 pi over 2. This is pi. This is 2 pi. And we want all the solutions here. So we need to go all the way across to this point as well. So this length here, again using the symmetry of the graph, so this length here corresponding to this length here. So if this is pi over 6, we need to do then 2 pi minus pi over 6. So if I pop this in, minus pi over 6, that gives us then 11 pi over 6. Oh, let's get the pen back to red. So if you're never sure about this, you can always do cosine of that, and that will get you back to the answer of root 3 over 2. So if you're ever unsure of any of these answers, all you have to do is go cos 11 pi over 6, and that will get you the answer of root 3 over 2. So every time you can check and make sure you're getting that particular answer. However, we also need the other answers over here. So notice this graph repeats every 2 pi. So I'm going to add 2 pi to each of these. Remember, 2 pi in terms of 6 is 12 pi over 6. So we've also got the answer of 13 pi over 6. And 13 pi over 6, and we're adding on, so 23 pi over 6. Notice there's also a negative answer here. Now this graph is symmetrical here. So notice if you type into your calculator, and this is good to explore as well, obviously not during the exam, if I do minus pi over 6, notice I also get root 3 over 2. So you also need to consider that minus pi over 6 is also a possible answer. And you can continue this process. What we're going to do now is essentially solve this. So first of all, I'm going to minus pi over 4 from both sides. First of all, so if I get 2 phi then, because this cancels, We then get pi over 6 minus pi over 4. Now with these kind of fraction calculations, of course, I know you can do this manually, but there's no reason why you can't just check on a calculator. Okay, how do I go about doing this? It makes you feel better in the exam. So this one here, for example, gives us minus pi over 12. We'll talk about the domain in a moment. So minus pi over 12, we have 11 pi over 6 divided by, or minus pi over 4. So again, just use your calculator here. And just change the numbers at the front. So we've got 19 pi over 12. Again, that's all I'm doing here, just changing numbers at the front. So it's a nice little exam tip for you. So 23 pi over 12. Again, kind of a laborious process, but it's worth going through. And then if I change this now to 23 pi over 12, get 43 pi over 12, and so on. And don't forget minus pi over 6 as well. So I'll change this as well. That gives us minus 5 pi over 12. If you need any more answers, we'll certainly come back to it. Now we divide each of these by 2. So if we divide all these by 2 here, we then get, and we have to check the domain at the end. So minus pi over 24, 19 pi over 24, 23 pi over 24, 43 pi over 24, minus 5 pi over 24. Okay, so let's check which ones actually lie in our domain here. Well, minus pi over 24 does. It's between minus pi and plus pi. Minus 5 pi over 24 is between minus pi and plus pi. 19 pi over 24 is. 23 pi over 24 is. This one is a little bit too much, so we don't need that answer. So these 4 answers are going to be the only solutions there. So again, just be very careful with domain, making sure you get all the answers that lie within the domain. And say I need an extra negative one, for example, I could always extend this and then read off this answer over here as well. Notice there is a symmetry around the y-axis here, which you can exploit for working out the negative answers. So for example, this would here be minus 11 pi over 6, and then you could work this out in a similar way. So you've got all 4 answers there, so making sure you get every single answer and don't miss anything out. That's really, really crucial. Okay, and on to a little bit of left-hand side equals right-hand side. So we've got this one here. So we'll start with our left-hand side and see what we can do with it. So minus tan theta over cosec theta. So the first thing that comes to mind is sec is equal to 1 over cos. 1 over cosec is the same as sine, so this just becomes then sine theta tan theta. And if we go from there, tan is equal to sine over cos, so we get sine squared theta over cos theta. And we've got the same denominator, which is very, very helpful here. So we can just go 1 minus sine squared theta over cos theta. And these kind of questions, you just need to sort of trust in the process that you'll get there. 1 minus sine squared theta, we did this identity on a previous slide. This one. So we're using this idea here. Knowing your formula sheet is crucial. So 1 minus sine squared theta is equal to cos squared theta over cos theta. Again, that cancels then to give us cos theta, which is then our right-hand side. So have confidence. Just the key thing here is put everything in terms of sine and cosine, and then let things simplify down to what you need to get. From there, and this is a very common kind of question here, is now using what we've just done, because notice this is exactly the same, but instead of theta we have 2 theta. We need to solve this equal to root 3 over 2. So notice we can change this whole thing to just cos 2 theta. Something to look out for here. So cos 2 theta is equal to root 3 over 2. We do inverse cosine of both sides. This cancels, giving us 2 theta. So we have to work out theta in a moment. And then the inverse cosine of root 3 over 2. Now working in degrees, so keep track of this. Again, don't be lazy and just leave your calculator where it is. So I'm definitely double checking these things, right? It's in degrees, perfect. So you should know this exact value already, but you just pop it in your calculator in case you forget, and then you'll get the first answer, which is important here, of 30 degrees. Now we actually did this already with the previous diagram, but again, it's worth just going through again. So we've got our cosine graph, down, up, down. We've worked out the 30-degree answer. We want the answer over here. Notice this here is 360. This length is the same as this length. So we do 360 minus 30, which gives us 330 degrees. We're doing it between 0 and 180, so you probably won't need any extra answers here. So we just divide by 2. You could, if you wanted an extra answer here, and it keeps going down like this, then 390 would be the next solution. If we divide by 2 here, this cancels, giving us theta is equal to 15 degrees. 330 divided by 2 is 165 degrees. Dividing that by 2, 185 degrees. Yeah, and that's beyond our domain. It's beyond 180. So we just have two solutions here. Theta is 15 degrees and 165 degrees. And the last part of the question, so now we need to solve this equation. Again, we approach it in the same way, get sine on its own. So we've got 2 sine squared phi plus pi over 3 is equal to 1. Radians this time, keep track of these things. So we divide by 2 on both sides. That gives us then equal to a half. Then we square root both sides, so we get then sine. So we have to be careful with square rooting because you get two answers. We're going to get the square root of this, so 1 over root 2 with the plus minus. Okie doke, and then we want inverse sine of both. So I'm going to treat this in two separate scenarios here. So we've got sine phi plus pi over 3. We'll start with the positive one, so 1 over root 2. And we want between 0 and 2 pi radians. So we want the inverse sine of both sides. So that then gives us phi plus pi over 3 is equal to the inverse sine of 1 over root 2. You should know that exact value being pi over 4. If I draw a sine graph for you over here, so yx, and we're working in radians, so we've got pi over 2 here, pi 3 pi over 2. This will help us with the other solution as well, and 2 pi. We've worked out this one, so pi over 4. We also need this one as well. So this pi over 4, pi over 2 plus pi over 4, that's 3 pi over 4. So that's another solution. And then the next solution, if we continue, would be, because it carries on like so, would be 8 pi over 4, and add an extra pi over 4, so it'd be 9 pi over 4, using the symmetry of the graph. And this continues. Do we have to think about the negative? I think we do here. So it goes this way. We might need to worry about negative later on. But now all we do is minus pi over 3 from both sides. Again, I'll just rely on the calculator to do this for you. So let's look at the solutions here. So you get pi over 4 minus pi over 3. That gives us negative pi over 12. That won't be a solution because it's beyond 0. So we don't have to worry about that one. Just be very precise with these things. So we get 5 pi over 12. That does lie between the domain that we have. And then 9 pi over 12. I suspect that will lie within the domain. It's just a shift basically. So we get 23 pi over 12. That just sneaks in to our domain because 2 pi radians is the same as 24 pi over 12. So I think those are the only two solutions from the positive. And now let's look at the negative. So we have sine phi plus pi over 3 is equal to negative 1 over root 2. So again, if we do inverse sine on both sides, we get phi plus pi over 3. Let's see what our calculator gives us here with the negative version. So we get minus 1 over root 2. That gives us this one down here. So it gives us minus 45 or minus pi over 4. So minus pi over 4. I'm going to write that down. But we want all the other solutions over here. So we want this one and we want this one. So that's going to be then pi plus pi over 4 is 5 pi over 4. And then we want 2 pi minus pi over 4. That's 7 pi over 4. And that should be enough in terms of solutions. That is supposed to be a phi. And then we're going to minus pi over 3 on both sides. Let's see how many other solutions that we get as well. Probably 4 solutions in total. So we get phi then. So do minus pi over 4 minus, that's going to give us another negative. So this solution is not going to work. So let's just pop into our calculator then. 5 pi divided by 4 minus pi over 3. That gives us 11 pi over 12, which does lie within our domain. And then 7 pi, which gives us 17 pi over 12, which also lies within our domain as well. So our final answer, I'll make this very clear for the examiner. We have 5 pi over 12, 11 pi over 12, 17 pi over 12, and 23 pi over 12, which gives us all the almost dropped it. Gives us all the solutions for this particular quite tricky trig equation. So you can check your answers there. So have a look through exactly how I've actually worked that out. So hopefully that is useful to you. And if you want to catch up on all things iGCSE Add Maths, so the entire course in best part of 2.5 hours, then do watch the video in front of you. Whether you're doing paper 1 or paper 2, that'll really get you up to speed with all these key topics. Again, I like going into depth with things like trigonometry and calculus, but if you want an overall view of the course, that is the video to watch. I'd highly recommend you watch it.